What is the hybridization of the orbital containing the unshared pair of electrons on the nitrogen atom and pyridine, right? That's pyridine. So the hybridization of this orbital, right, containing these electrons. So we want to figure out this N, what it's hybridized with. And we'll figure out how many pi pairs of electrons are connected to this N. So right here is a pi bond. There's a double bond there, right? So we have, well, here's a bond to one atom, this, and a lone pair. So this guy is going to be sp2, right? We determine the hybridization of an atom based on how many atoms it's bonded to and how many lone pairs of electrons it has. So this is bonded to a carbon, so two bonded to two atoms, or you could say it has one double bond and one single bond, so two bonds, whichever phrasing you want to use, and one lone pair. So that's 2 plus 1, 3, right? 1s, 2p, 3. So the trick is, don't get fooled into thinking these are pi electrons. These are not pi electrons. They cannot be delocalized here, right? This double bond can be delocalized. I believe there are, right, we have seen examples where lone pairs of electrons can be delocalized and therefore are pi electrons. I think, let me think, if I did something like, hopefully this example will work. Well, okay, right? So if we had here, right, then these guys are pi electrons, right? Because they can be delocalized. So, for example, we could move this pi bond here. It would be positive charge here. We'd have to do something like this, right? So we could show resonance. So there can be cases where a lone pair is part of the pi electron cloud, but not in this case, right? These cannot be delocalized. So in the end, long-winded explanation, but sp2.